Hello guys, welcome to Ramta Solutions. Welcome to your lesson on trigonometric graphs. Today we are looking at tangent graph. So these parameters A, B, P, and Q, they still mean the same thing as was the case on sine and cosine graphs. However, we're going to expand more on the value of B. Okay, so without any waste of time, let's get into it. And do note, at the end of this video, you will know how to draw this graph. Okay? Right. So we have, let's say, let me use a black color. F of x equals a tan bx plus p plus q. I will tell you now, A still represents the amplitude, P still represents horizontal shift left and right, Q still represents vertical shift up and down. One, I want us to talk about this B. We said it represents the scaling factor, or what you call the step signs, right? The scaling factor. You will say it is, normally what we do, we say it is 90 divided by 2b, right? We say it's 90 divided by 2b, but why not simplify it and say this is simply 45 degrees over b? It's easier to solve, to rather draw tangent graphs when you use the scaling factor, okay? Because if you can say, just say you're given tan 2x and your scale is 90, 90, 90, you won't really see what you're supposed to be getting. But if you use the scale, you will never go wrong. Secondly, it will give you a period. It will give you a period. So this period, when you were doing sine and cosine graphs, your period was 360 divided by b. But this time around, it is 180 divided by b. You will see later that normally this tells you when you get asymptotes. Talking about asymptotes, this also gives you the location, right? This b also gives you the location of asymptotes. Okay, it also gives you the location of asymptotes, where you will say your asymptotes can use this formula. Let's say 190 degrees. Okay, I will say it is 90 degrees plus 180 degrees k all over b. Note, k is an element of an integer. So if you are plotting your graph where your domain is 0 to 360 degrees, you must start with k equals 0. It'll give you exactly what you are looking for. Okay, all right, perfect. Now, remember I said A, P, and Q, they mean the same thing as was in, cosine and sine graphs. So for now, because we are looking at the tangent graph, I'm not going to dwell much on these. We dealt with them in the previous videos. So I'm going to give you an example where we are also going to sketch these. So, example, given f of x equals tan x and g of x equals tan 2x. 1. State the period and the asymptote. Okay, state the period and identify the asymptote. I think this is all we can say. And then 2, draw the graphs Of course, when x is an element of 0 degrees included and 360 degrees included. Okay? This is the example that we are going to look at. Okay. So, all this information we have here. Now, let's get our solution. What color should I use? Nah, it's not nice. I don't like it. Let me use red. So, number 1, given f of x equals tan x and g of x equals tan 2x. Right? Our period is 180 degrees over b. Alright? What is the value of b? Remember, these have the form y equals a tan bx plus p, close bracket, plus q. Okay? So as you can see, b equals 1. So this is 180 degrees over 1. So here is it. Our period is 180 degrees. For g of x, our period is 180 degrees divided by, what is the value of b? It's 2. Our period is 90 degrees. Okay, our period is 90 degrees. Now, let's find asymptotes. Let's find asymptotes. So, to find asymptotes, I said to you, the formula you are using is x equals 90 degrees plus 180 degrees k all over b, where k is an element of an integer. I will begin with this one here. So this is x equals 90 degrees plus 180 degrees k over 1, while this one here is 90 degrees plus 180 degrees k all over 2. Okay, so this is basically 90 degrees plus 180 degrees k, while this one here is 45 degrees plus 90 degrees k. Okay, so you are going to use your calculator. Okay, you are going to use your calculator, where you will say, first thing first, take this as f of x. So go to mode. On my calculator, the table option is option 7. I don't know what it is on your calculator. I'm using Casio FX991. So I'm using Casio FX991. So I'm using Casio FX991, and of course, Imzant. Okay, so this is mode. This is mode, and then you then go to option 7, which is table. Okay, which is table. You then go to option 7, which is table. Then you say f of x equals 90 degrees, or 90 plus 180. Okay, alpha, and then press this button here. This is for x. So your calculator will be showing you on your screen, your calculator will be showing 90 plus 180 x. Okay, 90 plus 180 x. If you are using Casio, most of you are using Casio. Okay, so it'll show this. Now g of x, for g of x, and then press equal to when you're done. Okay, when you're done, press equal to. Your g of x will be, let's go back, it was 45. So it's 45 plus, I think it was 90, right? 45 90 alpha. Yeah, it's alpha. Alpha is next to your shift button, and then the close bracket option. On top of it, there's an X. Okay, so your calculator will be showing you 45 plus 90x. 45 plus 90x. Now, your start 1 press equal to, we start at start press 0. Okay, for your start press 0. For your start press 0, not 1. So press 0 and then equal to. Okay, and then your end, they gave you 5. It doesn't matter. Even if you say yes, it's fine. So 5, you can say yes because I don't think we will need that. So press equal to. Step, they said it's 1. Remember, I said k is an element of an integer. So the step will be 1. So they wrote 1. So just press equal to. Okay, just press equal to. Okay, remember, we will take values of x that are between 0 and 360 degrees. Okay, going back, you will take values of x that are between 0 and 360 degrees. So they are, for f of x, they are 90 degrees and 270 degrees. These are our asymptotes. You will see what we mean by asymptotes. Now, for g of x, they are 45 degrees, 135 degrees, 225 degrees, and 315 degrees. This is where you find your asymptote. Okay, this is where you find your asymptote. Okay, we can't go to the other values because they are outside our domain. Okay, they are outside our domain. So as you can see, for f of x, we have 2 asymptotes at 90 and 270 degrees. But for g of x, we have 4 asymptotes at 45, 135, 225, and what is this? At 315. There's something that I want you to see. We said the period was 180 degrees for f of x. Now, since the period was 180 degrees, you can see the difference between the asymptotes is also 180 degrees. For g of x, the period was 90. When you look at the difference between the asymptotes, it's also 90. Can you see that? It is also 90. Okay, perfect. Now, we are done. Now, let's sketch the graph. I will need to go to a new page. Now, let's look at f of x equals tan x. So, obviously, the step here is 45 over b, which is 45 degrees over 1. This is 45 degrees. So, xy, xy. So, we have, I want you to notice we will use 45, 90, 135, 180, 225, 270, 315, 360. Okay, so now on your calculator, press AC on f of x, clear that, by pressing AC until f of x clears. Tan alpha x. G of x, delete it or press AC if we don't have it as yet, and then press equal to. We start at 0. Sorry, my mistake here. We start at 0. I forgot to include the 0. We start at 0. Okay, we start at 0. And then we end at 360. Can you see that? It's 360. Our step, we said it's 45. So step is 45. What you are going to get is this. At 0, your calculator returns 0, 1, error. Alright? And then -1, 0, 1, error. -1 and 0. Now let's try to plot this. Let's try to plot this. Okay, I hope it's not too long. All right, so this is 1. This is -1. Let me just do this. All right, so this is 90 degrees. Too big. This is 90 degrees, 180 degrees, 270 degrees, and 360 degrees, right? And 360 degrees. Okay, perfect. So this is 0, this is y, and this is x. So when x is 0, y is 0. When x is 45, here is it, y is 1. When x is 90, y does not exist, so we draw this line to say it's an asymptote. When x is 135, y is -1, here is it. Oh, 135, what am I doing? 135 is here, -1. When x is 180, y is 0. When x is 225, y is 1, here is it. When x is 270, the graph does not exist in this region. When x is 315, y is -1, where is it? Y is -1. When x is 360 degrees, y is 0. So your graph looks like this. Okay, your graph looks like this. Okay, your graph looks like this. Let me erase this, and then you will see. Can you see that? So this is how our graph looks like right now. Okay, this is how our graph looks like right now. Okay, can you see that? As you can see, the first asymptote is at 90 degrees. The second is at, or is it? The second is at 270 degrees. Let's confirm. Yes, this is what we said. Can you see that? Perfect. Now, we are okay. We can now proceed to find the g of x. G of x, oh my. So g of x, we said g of x is tan 2x. This means the step is 45 degrees over 2, right? Which is 22.5 degrees, right? Okay, perfect. So you are going to say this is, now go to your calculator. In place of f of x, now say f of x equals tan 2x, close the bracket. Right? G of x, we can leave it for now. We're still starting at 0. We're ending at 360, but our step is 22.5. Okay, our step is 22.5. So for this one, I'm going to really make it a bit smaller. X and y, the values are 0, 22.5, 45. We might finish next year. 66.5, I believe. 67, yeah, 67.5. 90. Oh, 112. Hi. 112.5. 135. 157.5. 180. 202.5. 225. 247.5. I'm sorry guys, this looks like a waste of time, but please bear with me. 270, 295, 292.5, I believe. 292.5, 292.5. And we'll finish next year. Let me just continue with it here. 292.5, 315, 337.5, and then 360. Okay, so let's get the corresponding y values. I don't like this, but there's nothing I can do. So when this is basically, well, done. Okay, so now let's see. So when we have it in this way, we say 0 degrees, corresponding y value is 0. At 225, we get 1. At 45, we get dash, right? Minus 1, 0, 1, dash, minus 1, 0, 1, dash, minus 1, 0, 1, dash, and minus 1, 0. Okay, so let's try to plot it. Oof. So, okay, let's try to plot it. Okay. Okay. So, we have 90, 180, 270, 360. Okay. So this is minus 1, 0, and 1. This is x, and this is y. This is 90 degrees. This is 180 degrees. This is 270 degrees. This is 360 degrees. So when x is 0 degrees, y is also 0. When it's 1, when it's 22.5, which is half of this, it's 1. Here is it. When it's 45 degrees, the graph does not exist at that point. Okay. You know what? Maybe let me just use a different color to have this, because I really can't be using this. Okay, let me use a green color. Okay, I'm gonna move it. Yes. We also find it at 135. 135 must be here. We also find it at 225. 225 must be somewhere here. Okay, 225 is half. Okay, 225 is half of that. No, it's not half. 225. Yeah, 225 is half of this. So it's here. And then we also find it at, oh boy. we also find it at 315. So 315 must be here. Yeah, 315 is here. Okay, perfect. Now, let's continue. So when x is 45, it's undefined. When x is 67.5, we get -1. Here is 67.5, we get -1. When x is 90, we get 0. When x is 112.5, we get 1. It's half of this. When x is 135, we get undefined. When x is 157, we get -1. Here is it. When x is 180, we get 0. When x is 202, we get 1. When x is 225, it's undefined. When it's 247.5, we get -1, 0, and 1. When it's 315, we get undefined, and 337, we get -1, then 0. Okay, then we can join this. Then we can join this. Okay, can you guys see that? So this is the graph. Let me remove this background. Okay, so this is the graph. Of g of x. Can you see that? This is the graph of g of x. Indeed, there are 4 asymptotes at 45, 135, 225, and 337,5. Let's confirm them. Oh, 315. Yes, 315. What am I saying? 315. Right? At 315. So here are they confirmed. Can you see that? So we were able to find where these guys were without drawing the graph. But now that we have drawn the graph, we have confirmed them. And as you can see, we said the period is 90 degrees. As you can see, everything is happening in 90 degrees. Go to the previous, everything is happening in 180 degrees. But here, it's happening in 180 degrees. So before you get the next interval, it only takes 90 degrees to get the next asymptote. Can you see that? And this is how you deal with tangent graphs. Okay, we are not going to look at horizontal and vertical shift. We mentioned them in sine and cosine. They still mean the same. Okay, they still mean the same even for tangent graphs. So this is it, guys. And I know when you look at tangent graphs, you're like, yay, what is this? But yeah, it is like that. Okay, so this is it, guys. Bye bye.